So you've already learned a little bit about rare earth elements, what they are, why they're important. My name's Kaisa, and I'm early stage researcher number 3 for the Panorama project. My topic is, does soil rare earth element speciation control rare earth element phyto-availability and dissemination within plants? I'd really rather use my time with you to talk about my research topic than my background. If you're really curious about my qualifications, you can always check out the following QR code, which should link to my LinkedIn page. Let's talk a little bit more about the speciation of rare earth elements. Typically, when we talk about the speciation, we can break it down into 2 categories. The first category is chemical speciation. In typical environmental conditions, we see rare earth elements in their trivalent oxidation state, associating with carbonates, hydroxides, and phosphates. We can also look at the physical speciation of rare earth elements. Physical speciation describes the size of the rare earth element. Some size fractions that we are interested in include the dissolved fraction, which is less than 1 kilodalton in weight, the colloidal fraction, which is between 1 and 1,000 nanometers in diameter, or the particulate fraction, which is 1 micrometer or 1,000 nanometers in diameter or larger. It's also worth noting that when we discuss physical speciation, there are unique surface properties for colloids. Colloids tend to be relatively stable in fluid suspensions and can pass through filters, thus making them of interest when we talk about the fate and transport of a contaminant in the environment. Additionally, the surface chemistry of colloids can be quite complex. Taking rare earth elements as an example, we see the attraction of oppositely charged anions to the colloid rare earth element surface. And when the collection of charges is sufficient enough, we see the charges begin to be balanced, and the attraction of cations to the concentrated anions surrounding the original rare earth element colloid. Now let's take a closer look at some of the plant processes that might control rare earth element mobility. The rhizosphere is the interface where the plant meets the environment and acts as the gatekeeper for phytoavailability. Since plants can't just move whenever they would like, a lot of the way that they survive in their environment and obtain nutrients is by manipulating the rhizosphere. Some of the manipulations that you might see in the rhizosphere include alteration in physiochemistry. This would be changes in pH and redox potential, as well as the production of biogenic exudates, including low molecular weight organic acids such as acetate, gluconate, and oxalate, which mine for otherwise insoluble nutrients like iron and phosphate. Both iron and phosphate can be important associations for rare earth elements. Additionally, in the rhizosphere, we see the breakdown of organic matter by microbes. A common byproduct of organic degradation is humic and fulvic acids, which can be colloidal and an important surface for rare earth element binding. Putting everything together now, my project will look at geochemical factors such as the soil minerals and the soil solution, and biological factors like the microbial mass, subterranean tissue, and aerial tissue to determine where rare earth elements are distributed as well as what their speciation is. Hopefully, the information that we collect will help us piece together something about rare earth element phytoavailability. I'm really happy to have been able to explain my project to you. Hopefully, you'll keep following the Panorama project. Until next time.